Hi, I'm Chris Bogart. I work with the Institute for Software Research at Carnegie Mellon University. I'm going to talk today about work done with Daniel Klug and Jim Herbsleb, also at CMU, investigating how an open source software community uses roadmaps to coordinate effort. So, collaboratively built open source software increasingly takes on the role of infrastructure. And infrastructure has to be maintained. It has to be stable and predictable for the people that use it. Some infrastructure, bridges and so forth, are built by governments or corporations with deep pockets that can hire and direct people. But how can this stable predictability work in the free and open source software world where volunteers only work on what they feel they're motivated to work on? Even developers paid by companies are only going to work on what the company values. So how do people choose big new features that take many hands to build? How do they keep little new features from conflicting with each other? In general, it hasn't been clear to researchers how open source projects match the supply and demand of maintenance work. And in fact, we know that this sometimes fails, for example, with the Heartbleed bug. Some researchers have pointed to at least some ways that open source leadership can guide a community by describing their vision, by laying out schedules and roadmaps, describing collaboration guidelines, propagating norms to newcomers. But we feel that there's more to be learned about how this works. So we looked into this by choosing a particularly open, transparent planning technique that's used by an open source infrastructure community. That is the roadmap process that the Rust compiler community uses, specifically the work and discussion around their 2018 roadmap. So I've summarized some of the methods that we used on this slide, but I'll bring them up as needed in the next few minutes. So our research questions were basically, how did this open source community make use of a roadmap, and what functions did they intend that roadmap to serve? So why Rust? Well, so Rust is a systems programming language. It was originally released in 2010. It emphasizes performance and reliability. It is infrastructure. It's used by a lot of internet companies, including Mozilla and Facebook and many others. There are thousands of contributors, and it's a very open, observable process, so it was a good place to study how this kind of coordination happens. So the Rust community in 2018 looked sort of like this picture. There's a Rust core team of 9 people. 191 people were on other kinds of Rust teams. I've listed a few of them here, but they have to do with different aspects of the Rust compiler or tools surrounding it or aspects of it. And then there was about 2,500 other contributors to the Rust community. Now in this paper we draw comparisons between team and non-team activity, and when we do that we're talking about this set of 191 people as opposed to the rest of the contributors. And we avoid using Lev and Wegener's terms core and periphery just to avoid confusion with Rust's use of the word core for this smaller group, but that's the concept we're talking about. So you might imagine that some core group with a vision lays out a plan, says what work is needed, and then asks the community to contribute the necessary code. But that's not really the case. In 2017, the core team ran community and commercial surveys to find out broadly what people wanted from Rust. And then they asked for blog posts with ideas for the upcoming year. And 100 people wrote blog posts. 18 of them weren't by team members, but most of them were non-team members, and 3 of them weren't retrievable. So using these blog posts and the surveys, the core team assembled a roadmap in March 2018 and put it out for approval by the community. It laid out priorities for the compiler development and for community development, a rough schedule in kind of 2-month chunks throughout the year, and describing its rationale, drawbacks, alternatives. So, and then after the roadmap was written, there was a discussion period, but changes were pretty minor to it. And that isn't really too much of a surprise, because they drew heavily on what people willing to do work for Rust in the form of these blog posts wanted. So in a sense, the roadmap is biased towards what the most productive, engaged people already want to work on. And so one of the conclusions we draw is that the roadmap is more of a collaborative prediction than a direction. It believably describes the future direction that the Rust community is going to go because it summarizes what the most productive developers want to work on. They describe what motivated labor is available. So in that sense, it's a believable prediction about the future. So the next thing you might wonder is, after the roadmap comes out, does the community just do what's in the roadmap? Well, sort of. So we analyzed the roadmap and identified 34 different topics that it covered, kind of compiler improvement efforts that they favored. And we came up with a heuristic for classifying all of the work, all of the issue threads, all of the pull requests and code contributions in terms of these 34 topics or in terms of non-roadmap as the sort of 35th topic. And we used just mass volume of text and code as a rough estimate of the amount of work that went into roadmap or non-roadmap topics. Obviously, that's just a rough estimate, but it gives some idea of whether the roadmap was followed. And you can see the details in the paper. It was a fairly elaborate process. But as you can see here, most of the work, most of the issues that were discussed, most of the text at least, was non-roadmap text. And most of the lines of code was non-roadmap code. However, if you divide that number by the number of issues or pull request threads, well, then you can see that the roadmap discussions are bigger and the roadmap pull requests have more lines of code. So in other words, if you look at the top issues or pull requests in terms of size, most of them will be in the roadmap. So there's a lot going on in this community. The roadmap doesn't limit what goes on, but in some way it appears that these topics are more complex or controversial or worth talking about or something so that they get more than their share of work. Another way we triangulated results in this study was an email interview. We invited about 200 people with a stratified random sample, sampling equally from team and non-team people. Ended up with 39 participants. Asked them a bunch of questions about their relationship and feelings about the roadmap. And so this person, relative to this question, said, a lot of other things outside the roadmap will be worked on, as you cannot command volunteers to do otherwise. So they can't command users, but in the end they did put a lot of work into roadmap issues. So how do they encourage that? Well, they did it in a couple ways. First of all, they used the roadmap as a resource for argumentation. Another method note, we isolated every mention of the word roadmap from all of the online forums and blogs and meeting chat sessions and issue threads. And two of us researchers did qualitative coding, identifying the discursive purpose of the word roadmap every time they brought it up. Why did they bring it up? So here we see some examples. In the first one, we see somebody kind of politely discouraging someone from pursuing a non-roadmap topic. Could be an interesting thing to consider for next year's roadmap. In the next one, we see a core team member more pointedly discouraging. There hasn't been a lot of activity in this RFC. It also doesn't particularly fit the roadmap. And then in the last one, we see a non-team member justifying work based on the roadmap. Using build systems other than, in addition to cargo, is explicitly a goal in the 2018 roadmap. Another way of encouraging roadmap work was to associate them with a team identity. And so we see a couple of examples here. In the first one, a team member talks about building teams around the roadmap. He says, the primary focus of this year's project is the domain working groups that we kicked off with our 2018 roadmap. And in the second one, they talk about building a mini roadmap for use within a team. A key step in any successful working group is going to be forming a roadmap. So they associate these roadmap topics with a team identity and introduce these people together and get them working together on these roadmap topics. Another purpose for the roadmap that we identified was bolstering this trustworthiness as infrastructure by creating a believable plan and exposing it to people outside the community. So a couple of the people in the email interviews, one of them said, the roadmap conveys a sense of which unstable features are okay to use in a project that's planning to switch to stable in a reasonable time frame. The other person who was a little bit more skeptical about Rust said, I consider Rust to still be a young language that's not yet finalized. Depending on the direction it goes, it could be a deal breaker for me. So this is a case study of one community's actions and intentions around a roadmap. We don't conclude how it generalizes to other communities. Rust is a very particular community that's quite open and verbose. And we also don't claim that it was the best method for them. It could be that if they'd used some other method than roadmaps that they would have done better. But there are some kind of existence proofs that we can learn from about this. So first of all, that listening to the community in an open process doesn't have to mean losing focus or direction. Also, synthesizing the intentions of the most engaged contributors can help form a consensus about direction. And finally, a roadmap can guide significant progress without preventing work on other things. Thanks for listening, and check out the paper for more details about the methods in our results.